Okay, so in this video, we're going to discuss data structures and data types in R. Now, basically in R, you'll be dealing with data, so it is important that you know how to go around the various data types and the structures so that when you have data, you can store it in a way that when you have to do some computations on it, it will be easier and then it will not result in errors and so forth. So that's the focus of this session. Now, so when we talk about data structures in R, there are basically 5 types. Now, depending on the book that you are using, it may be 6. Okay, and the reason is simple. In some books, they classify factors as a data structure, but here and some other books, we will classify a factor as a data type. And the reason is simple, because a factor is just like a vector. Okay, so just that it's under, you can have it under either a nominal scale or an ordinal scale of measurement. Okay. So the first data structure we talk about is called a vector. Vectors. Vectors. Now, so a vector in R is just a one-dimensional array, right? So basically, an ordered collection of objects of the same type, right? So for example, if I talk about age as a vector, I collect data on age, then I'm going to get numeric, right? Because they are going to give me numbers. I ask you, what is your age? Maybe 23, 25, or 40, or 60, and so forth. So it's a collection, okay, of objects of the same type. Now, if I ask you of your religion, you're going to say maybe a Christian, a Muslim, and so forth. Okay. Of course, we can code Christian and so forth as one, maybe Muslim as 2, and the other religions 3, and then maybe 4 for others, right? But such values are actually representative of what? Of a specific group. Okay. So now let's see some vectors, right? So C maybe 23, 24. The next person is maybe 18, 36, and maybe a pensioner, 67. So here, what I need to do I have written this vector, but I have not run it. So you see my environment is empty. On my console too, I don't have anything over there. So what do? I run this, and age shows here. It says that age is what? Numeric, and it is made up of what? 5 values. Now, I can also define religion, and religion, I may have a Christian, a Muslim, a traditionalist, Let me enter that. Hindi or maybe another Christian. And we have 5 now. Okay. So I do it like this. So you see, this is also a vector, but that vector is made up of a data type character. So you see, the structure is the vector, but it constitutes the type. That type you have in that structure is a character, and this one is numeric. Okay. Now I can also have another one, which is let's say logical. So I ask whether we'll vote. So let's assume that we ask whether you vote in the next election. And then somebody said, true, I'll vote. This one says, I'm not going to vote, false. The next person may be false. The next person, true. And the next person may be false. Now, if I run this, that's also a vector, but it is made up of what? Logical data types. So R has these data types. We can have dates, missing values, and so forth. But for now, we will make do with this because we will come back to data types later on. Okay. Now, so what we have realized is that for functions, sorry, for vectors, so use what we have, we use what? Use the C, we call it the combine function to create a vector. But there are other ways that we can also create vectors. And this one, it's about how to create what? Patterned vectors. Okay, well, what we did up there, you can, it may not follow any pattern, but here we want to use pattern vectors. And there, we can use the colon. So the colon is to create a pattern vector where we have sequence of numbers, and the differences are only one. So sequence of numbers with a difference of 1. So consecutive differences 1. So example is that I can do 1 to 100, 1 to, let's say, 10. If I run this, it gives me 1, 2, 3 up to 10. So that's a vector. I can assign it a name like int, and there this is an integer vector, and it is so because R generated this, and we say 1 to 10 instead of 1. So it takes this as a whole number, an integer number, right? Okay. And 2, we can also create numbers from what? Let's say negative 22 to 5. We can do so, right? So there is also integer. Okay. It will start from negative 20 right down to what? To 5. Okay. So that's it. We can also move in terms of like descending order like we have done. So the next one is sequence. Remember, it's not every time that you move in steps of 1. So here is a general sequence. So when general sequence. So here we can do it in any form, either in steps of fractions, what have you, or multiples, whatever we can use it. So first of all, if you don't know anything about this, what you do is to do the help out. Okay? We say sequence generation. So this generates sequence of observations, and this is how this is done, right? It's like this. So I copy and paste, and then I'll explain what each of these things are. So you move from one to the other. Okay, so 1 to like 10. Okay. Remember the previous one, we move in steps of 1. So if I were to do this, I'll say by 1. Okay, so I'm going to run this. You see, it's 1 to 10. Okay, if it is, let's say, 20, 10, it will move in descending order. Yeah, so you can't use ascending order in this way. We must reverse it. We can do so, but we can use reverse to reverse it. Yeah. So here, let's say if we were to move to 50, it's like this. Okay, like that. Okay. We can also move in steps of, let's say, 0.1, okay, or maybe 0.5. So here, you see, 20, 20.5, 20.1. So by can be anything. Okay, can be anything. But you see, it must be what? A positive number. So when you come here, you see from to the starting, okay, and maximum end. So that's why when we do it like from the bigger value to the smaller value, it doesn't work because ours programming that your from should be what a smaller value to the maximum value. And the by is what the increment of the sequence. The length out is the desired length of the sequence. So I'll explain what this is. If I want to, let's say, get 60 observation between 20 and 50, right? All I need to do is that I don't have to now search for what differences or by will give me that 50 observations. All I need to do is to say length out, length dot out. So length dot out is 50. Okay. So I will just divide those into and give me those. Right. So that's the sequence, and that can also be used to create a vector. Now, then the last one is replicate. So okay. So here is just replicate numbers, right? Replicate elements. Okay. Now, so what do we do here? Let's look at some examples. Okay, so let me go to the help file so you know how this is like. So it replicates elements of vectors or lists. All right, we'll talk about list soon, so you know what this is. So times, length out, and there's even each. So let's look at some more examples. So replicate, let's say 9, 4 times. It means I'll get 1, 2, 3 up to 4. No, 9, 9, 9, 4 times. Okay. So this is the same as times. Okay, if I should replicate into your time. So that's okay. And then also I can take some vector, right, and repeat it. So 4, let's say 3 times. Okay. So you see here, it takes 1, 2, 3, 4, and then repeat it, and so forth. but I can also say each. Okay, so I can also say each, and then here to repeat each number 3 times consecutively. So note the difference between the. So R makes life easier if you have to do some repetitive. You need to, be writing all the way. So 1 to 10,000, then you start writing 1, 2, 3, and 2. You can just say 1 is to 10,000. That's it. So that's it about how to create vectors. Now the next thing that we look at is how to reference elements of a vector. In other words, we can also do a subscriptive, that is retrieving. How do we retrieve elements in a vector? Okay. So let's say that is 1.1. Referencing. A vector. Okay. So here we use the two ways. Okay. One, A, we can use this, so the square bracket. Now, how do you use it? You need the name of vector. Okay, then the square bracket, then I, where I is the position of the observation. So, example, let's look at age. Okay, so if we want the third person's age, we do this. 18. If we want all other ages except the third person, we will do minus, then we get that. Now, if we want more than one, we can input it in as a vector. So let's say we want 1 in the fourth, like that. If I negate that one, it will display all ages except 1 and 4. So that's about saturating with the and here we can also be using names. Okay. Now here we will still use a square bracket. So use a square bracket. However, what we will put in is not the numbers, but rather the name. So to do that, we are going to name our vectors before, right? So names, so how to name, so we are taking the opportunity to name vectors. Okay. So the vector should be character. So character, and now we put them in quotation marks. Okay, so Ali, the next person maybe Abba, next person maybe Sai, the next person. Amma. So these are the 5 people. Okay. So now, if I want the age of the third person, I know the third person's age, name. It is Sai. So I put Sai in here, and it retrieves the age of Sai. Okay, but the spelling must be right. And so if I want more than one, I must put it as a vector now, right? So Sai and baby Ali. There. So that's how you can saturate or reference elements in a vector. Now there are some useful functions. So useful vector functions. I can name this as 1.2. Okay. So vector function. For example, we can use which. So this is a query. So I can say that which age is greater than 25. In other words, who are the people greater than 25? So here it will give us just the index of the logical expression, because look over here, I'm going to get true or false. Let me, if I do this, if you are greater than that, okay. So it is just finding out which of these people are over 25 years, and it is those amount and whatever Abi, but they are in one position, fourth and fifth. So that's how which will query a data set. If I want to get the exact ages of those people, then I must put this one in a square bracket so that when it is done, it will extract those that will say true. Okay, so that's one way, which is which function. There are a couple of them. We can also get which dot min, which dot min. So in other words, which one is minimum? Then if we have which dot min, then definitely we should have which dot max. Which dot max. Okay. So here, if you query a vector with this, what it is going to do is to find the position of the minimum value. So which dot min age, right, will be the third person is the youngest one, which is 18. It means, and then I can also do which dot max. And then okay. So these are some of the observations. Remember, if you want to retrieve the exact age, you must pass it through the age function, waiting with the position that you see. There are other functions, several of them, to do addition, multiplication, find the minimum, maximum, minimum, maximum, and so forth. I'll show you some. And yeah, so you should look at this. Yeah. So sum will give us X prod will give us the product. Okay, cum sum will give us what? The cumulative sum, like a cumulative cumulative frequency function. Min will give us minimum, max will give us maximum, mean, median, variance of S, covariance, standard deviation, range, like a quantile, 5 num, and so forth. And 5 num will give us the two case, 5 number summary, minimum, maximum, and so forth. And the unique will give us what? The unique observations. Um, yeah, so about vectors. Now we move on to 2, which is matrices. So matrices, as we know in mathematics, matrices they are two-dimensional arrays. Okay, it has rows and what, columns, right? And so 2.1, creating matrices. Creating matrices. Now, there are three ways so that you can create a matrix. Okay, so first of all, using matrix. Okay, okay, so how do we do this? Well, let's assume that I want to create a matrix of the objects 1, 2, 3 up to 20. I want a 4 by 5. A 4 by 5 matrix, 4 rows, 5 columns. So what do? I may say I have my data. My data is 1 to 20. This should be column 1 to 20, right? Then let's say I call it mat1. That's the name. So I call a matrix function. Okay, it says it needs a data. It needs data. Of course, we can do this. Okay, help files, and then when you come here, you can copy and fill in. That's the easiest thing to do. Because I have been doing this for years, it's easy because I know whatever I'm looking for. But for the beginners, it's not so easy. So the easiest way is that you copy. These dim names, you can clear it because I prefer that we name it after we have created it. It makes life easier. So my data is the 1 to 20. Then my number of rows is 4. Number of columns, I can leave it, okay, because I know the total number of observations, and then I know the number of rows. So automatically, I know the number of columns. For the sake of argument, let's just maintain it. So, okay. Then by row is false. Now, this is a logical argument, which is false or true. By default, it is false. Now, if by row is false, it means fill this column-wise. If by row is true, then fill the rows. Once the row gets full, you move to the next column. So that's it. That's how it is. So we'll create the two, and then you see the difference. I'm sorry, I have not done this. So then, so you see, because this one by row is false, it fills it what? Column-wise. So it fills the first column. When the first column is done, it moves to the second column. And then the third, and then the fourth. Now, let's see. The next one is that we're going to create matrix 2, but that one we are going to make this to be true, like this. Okay. And then there. Okay. So if you, because the by row is true, you see it fills it this way. Then after that, it goes that way. So it is important that you notice how this is done. Other than that, when you have a data set, you end up giving somebody's age to the height of someone and so forth. It will mess your data up completely. So it's important that you take note of this as we move on. So that's one way of creating this. Then the other two, we put them together. So I'll say B is that we use cbind, okay, and then rbind, and we'll see the difference between the two. So cbind is just column binding. It means you are adding columns together so that, yeah, or if it is rbind, it means you are adding rows. In other words, you are piling up by some rows together. Okay. So how do we do this? To do this, we're going to create some more vectors. So let's look at weight. So weight, I can select weight, but just to have a feel of statistics, let's sample. We can sample the weight, okay, from let's say 60 kg to 140 kg, right? So sample is used to randomly sample observations. So it looks like this. So random sample permutation. So this is how it looks like. Okay. So I can copy this and then maybe we fill it in. Okay. So X is what you want to sample. Now, so here, what we want to sample is that we want data from 60 to 140 kg. All right. Then the size is the sample size. How many do you want? So in this case, we want 5. Then this one replace. If replace is false, it means, once you take the number, you cannot replace it to the next one. So it's just like when you are, let's say the Saturday Lotto that they do, they take 5 numbers. When the number comes out, you don't bring it back again. So that's replace is false. And for those sampling with replacement, it will be replace is all true. Okay, so this one we just noticed that we leave the default like that. Prop is also that we can assign probabilities to each data point, right? So let's say you go to a classroom and this classroom is made up of 80 students. 30 of them are 20 years, right? Okay, maybe 20 are 19 years. Okay, 20 for 8 people, and so forth. So you realize that a 20, they are more because they are 30. So you can assign that probability, right? You can assign that probability of 30, that will be 30 over 80 to the number 20, and then the rest you do it like that. So, yeah, but we may get there. So this is just something to put our appetite. So if we look at what we've gotten, is what 105%. So if I do it again, I'm going to get different results because this is random sample. So each time you get different results, right? And so forth. So if I want all of you to get the same results, what I'm going to do is to set the seed. Okay, so you provide it with a seed. The seed is any um, um, whole number, right? Positive whole number. So 1, 2, 3. Let's say we took 1, 2, 3. Then we do this. So this one, when we got this, okay. So I may repeat it. Anytime I repeat it, I'll get the same observation. Okay. You can also try at your end, and you'll get the same results. Okay. Now, yeah, so now we have our weight. Let's say we want weight, let's add height, right? Then height, there too, we can also sample observations from a distribution. So let's take a uniform distribution. When we say uniform distribution in statistics, it means you have an interval. Let's say you say that, okay, maybe in a class or you go to a particular meeting, and then you say this meeting is for adults. So the ages are from 18 to, let's say, 60. No one is a pensioner. If it is distributed uniformly, it's not biased, so you don't have so many people, um, yeah, around 60, and only a few are maybe below that. What you are saying is that everybody has an equal chance, okay, of being selected, something like that, okay. So we can use an expression called R unit and look at it. It says you need N. N is a sample size, minimum value and maximum value. So that's what I'm going to use. I will say N is equal to 5. In this case, we will have 5. And minimum value, this is height. So let's say 1.60, 1.60 meters. And then maximum, let's say 2.3. 2.3. Then we run this. We check the height, and it has six decimal places. I can round this one. Okay, so we can also round it, round the whole thing to 2 decimal places. So you say digits, round it. How many digits? You see 2. Okay. So if we rerun this and we do it like this. You see, the 60 doesn't take place. If I want to get the other one, I have to run it again. All right. So now, if we run height, we get to 180 and so forth. So now we have 3 vectors. Let's see how we'll use cbind to get our matrix. Okay. So mat3 is a cbind. Mat3 is cbind. So we'll have age, we have weight. Remember, they are all the same in terms of their length. How many observations are in there? Right. Other than that, we get, yeah. So mat3 is like that. Then let's look at the case where we use our line. So here you realize that it combined in a column wise. So here we're going to have what row wise, right? Oh, okay. So I have to redo this again. The mat1 and mat3 like that, and then mat4 like that. Okay. Now you see the difference between the R bind and the C bind. What you should know is that in statistics, we organize data like this. In other words, the columns are always the variables, and then the rows are always what the observations. So when you take Ali is 23 years, weight is 90 kg, and height is what 180, 1.8 or 180 centimeters. So this is not a good way of representing the data. All right, it's not good. Okay, you turn it upside down, and remember that we've yeah, we can now look at how do we retrieve observations from. So we've seen the basically 3 ways to construct a matrix. The next thing we do is that if we're able to construct a matrix, how do we name the columns and the rows, right? Okay. Well, this one we've named them already, but we would have used what call names. Okay. So mat3 is like this, right? If I want to rename mat3, okay, I would have done this, right? And then I provided it with 3 names. Okay. So maybe I can just add one to this, just so you know that you can use this too. now this is done. Let's see. Okay, so now if I call my 3, you see it has changed and so forth. Similarly, if we want to rows and columns, if we want to name the rows, we would have done so by saying what row names mark 3. But remember, this one, we can use it to do assignment. We can also use it to call the names. So if I do this, it gives me all the names of the rows. Yeah. Okay. Now let's move on to how we can reference observations in a matrix. Nothing more than what we know before. The only addition is that here, reference elements in a matrix. Okay, the only difference is that here we have rows and columns, so you have to provide positions for the rows and columns. Okay, so A or I, you use this. Okay, so name of matrix, and then the positions of the rows and columns. IMG are the row and column numbers. So, for example, in Math 3, let's assume that in Math 3 we want to obtain the weight of what side, right? Then what we are going to do is simply this. We can call Math 3 then psi is the third person, right? So row 3 and then column 2. Okay. So if you come here, size weight is what 110. Now we can also get some more, let's say 1 to 3. It means we want to obtain the result. How many rows? Okay, yeah, we want to obtain all the information for psi. There it is. Now another way to do this is that we could have just left it blank. Yeah, like that. Okay. Similarly, if we want the entire, let's say, columns, sorry, row values, what do? Let's say I want 3, all the, I do this, all the heights, I do like that. Okay, so that's how we can extract observations from this. We can also use the names, right? And the names, so okay. We can use the names and this one, okay. So the same thing we did over here, I could have said Math 3 was psi, so I'll say psi, and then I leave the other blank. So I got the same thing, right? Okay. So if I want psi, and let's say the weight and let's say the first two, uh, this thing. I can also do so by calling for the weight one and what? No, age one and weight one. So age one and then weight one. Weight one. So if I do this, I get that one. I can combine Sai and let's say Ali. Sai and Ali. In that case, I have to also put them in what? A C function and then get it like that. So surface is um, difficult, it's just like what we do previously. Okay. Um, then also remember that we can do several functions can be used on a matrix like transpose and so forth. I'll show you some of them. Some of the functions that can be used like this, right? So we can do matrix multiplication and so forth. Okay. Whatever you do in mathematics, you can also use R to do so. But this one, T is transpose of a matrix, so T is a keyword. So you don't name your object or your any object as T because it's a keyword, small letter, and the cap is for what? True. So that's also reserved. That is the determinant of determinant, right, of A. Then solve A and B, A comma B, what? A solve system of equations. So when we have a system of equations, A is equal to B. So if you can write your equations in that form, then you can quickly use how to solve it, provided it has inverse. Okay. Then if you there's a single solve A, will just use it, will find the inverse of that matrix. Then the generalized inverse too is in the mass package, so you can get it as G inverse A. We can obtain eigenvalues, Chomsky, factorization, or decomposition. We can diagonalize a matrix and so forth. Find lower and upper triangles quite easy. Okay. All right. So that's it, and you should look at some of these functions. Then the next thing is apply. Now, apply, we've seen R bind and so forth. Okay, so Jim will give us the dimension, number of rows, N row will give us number of rows, number of columns, call names, row names you've seen. Names are just both rows and column names, right? Okay, but this is dimension of A, okay, and so forth. So I'll briefly talk about apply, but it's also a video on apply function because they are very, very, very handy in treating or doing computations in a coming handy. Okay, so for example, Math 3, okay, the apply family. Okay, so some functions, some useful functions. And useful matrix functions. Okay, so a couple of them, but we are just taking apply. So apply is actually a family of of um, functions. So we have apply, yes, apply T, apply L, apply, and so forth. Depending on the data structure, you select what it is. But the basic form is apply. So its form is like this, okay? When you use it, it's like this. So I can say that ma3, okay, ma3, the margin, if margin one is for rows, okay, so if you put in one, then it means you say whatever you are going to do should be row wise, right? It should be done to each row. If it is two, then it means for each column. So for now, I choose two, and then my function is that I want summary. Okay, the rest I can take it off and use the default. So what do I mean by summary? I want summary statistics, right? So I do it like that. So you see age, the minimum age is what? 18. The first quarter is what? 23. Median, um, median, mean, third quarter, maximum. So forth. So that's how this apply. If I were to use one, it is going to calculate that for each row. But remember the rows, it means you are going to find the totals and whatever minimum for age, weight, and they are different units and so forth. So it's not advisable to be doing this, but for the sake of this, like this. So you see that the minimum will be only the height because those ones are in meters, and so for the weight will be on the height. As I said, there will be more videos on that one. But the key thing is that this you can use it to construct, let's say, contingency tables and what. Now, the next thing I'll talk about is data frames. Okay, data frames. So that's the third thing. Third, data frame. And this will be very brief because we've done almost all the things. Just some comments on that. Okay. Now, um, to introduce data frames, I want us to consider this. Remember, the matrix is what? A two-dimensional array or collection of what? The same data type. In other words, I cannot put logicals and what have you. We've seen some data like integer and characters and so forth together, right? So to be able to have a work around it, we do this. So first of all, let's just make the mistakes and notice how this is like, and then we change it. So remember, ma3, I can add religion, right? So that I attach religion to it. Let's see how the results will look like. You see, it has changed ma3. Ma3, we're able to compute summary statistics and so forth, but now all the values are characters. So even though A is showing 23, that 23 is what? Is a character because that's is a quotation mark. So now I cannot do any computations on it at all. In statistics, this will be under what? The nominal scale of measurement. Okay, so to get a work around this, we use a data frame. So the data frame is the same as a matrix. The only difference is that it can contain different data types. Okay, so to construct a data type, a matrix, sorry, data frame, we use the data dot frame, right? So you say data dot frame, okay, data dot frame, right? And I'm going to pass the same thing to it. Okay, so you see that after this one will it will just maintain its width. So consider the two. You check the two, they are different. In the data frame, age is numeric, okay, weight is numeric, height is numeric, but religion is what is the character and so forth. So if we do it, we can even see it at the environment, whereas this one, math 5, will be character. Like we see that DF math. Look at DF math. It says what? Age, numeric. You see, these are only religion is character, but math 5, they are all characters. You look over here, even though you see it that way, it says all character. So that's whatever we did in terms of subscripting or referencing and apply statements and whatever also apply to the data frame. Okay. The only thing that I want to add to this is that for the data frame, okay, if we want to access or reference the variables, it's easy. We can use the dollar sign, right? So df.math, okay. If I want to access the variables, I can say age. So if I want age, there it is. Okay. If I want any other thing, all I have to do is to put in the dollar sign, and then I retrieve it. It becomes a vector now. So that's it's about data frame. Okay. And lastly, the last data structure we talk about is list. So the 544. So vectors, matrices, data frame, so forth. Okay. 5 would have been arrays, but we will not treat arrays, even list. Okay. So a list is the most complex data structure in R. So a list is basically a vector, which means a collection of objects, right? One-dimensional objects. The added advantage of list is that it can contain any data structure, including itself. Okay, so I can define a list within a list. Okay, so we create a list using the listing list, right? Okay. So as an example, we say my list. The name is my list. So list. Let's take a vector. So a vector could be age. Okay. That's character. So we can get another vector again, vector 1, which is the character vector. So let's say religion. So it is taking different data types. We can put in a matrix. That matrix could be what? 3. We can keep in a data frame. Which is what df.math. Okay. If we had a list, we could have put in a list as well. Okay, so let's see how this looks like. My list, if you say so, vector, matrix, data frame, and so it shows you all of them. You can also display it, and then each thing that is over there. So you see, different data structures can be compiled under a list. I can create a second list, okay, list 2. So this second list can contain even the list we have created earlier. Okay, so I can let's, there are some inbuilt data. So let me say state is state dot x77. It's a matrix. Okay, I can say that list is also equal to my list. Okay, so when I do this, okay, this is also a big list. Okay, it has what? The state, which is made up of 1 to 50 rows and 8 columns, and then it is made up of a list within the list. So that's what I mean by that. I mean by the whether it's the most complex, it can contain even its own structure, and so for any other structure. So referencing observations, referencing objects or elements in a list, what do we do? So it's just like a vector. So we can use a position. So my list one will give me what? The age vector, right? Okay. One more thing, we can also use like this. Okay, so to this. Okay, so now you don't really see, but look over here. You see here we have the vector over here, right? Here there's no vector. You see this if you save them. Okay. Let me say L1 is this, and let's look at L2, right? So let's save them. Okay, so the first one is a list. So I can check the structure of L1 to display as a list. So you see a list of 1. So even though we have a vector unit, it is stored as a list. Okay, and you remember that I said the data structure is important. But here it will just be a vector because it was just the name num, which is just a vector that has been named. So take note of that. And the way you retrieve it. We can also use the names, okay, to retrieve them, and also the dollar sign. Okay, so my list. Okay, if I put a dollar there, it gives me everything that is in there. So if I want a matrix, I do so. Okay, if I want another, let's say another one, a vector one, I do so like that. Okay, now yeah, and then you can also use the names, okay, of the vector to also retrieve them. Okay, so vector. So that's it about the data structures. So our next topic will be on data